Hello, my name is Amy, and I'd like to welcome you to NSPS and NESHAP Proposed Amendments, Navigating the Fenceline Monitoring Requirements webinar. Our speakers today are Jeremy Sell and Carrie Ward. They will provide information about the Fenceline monitoring requirements related to the proposed amendments and what you can do now to prepare. We're excited to get started, but first I'd like to go through a few housekeeping items. First of all attendees are in listen-only mode. If you have questions at any point during our time together, please use the Questions tab in your GoToWebinar attendee panel. We'll save a few minutes at the end for Q&A after Jeremy and Carrie are done presenting. If we don't get to your questions in our hour together, we'll answer them directly via email after the webinar. This webinar is being recorded. A copy of the recording will be available after the webinar. Finally, you'll have an opportunity to complete a short survey when you exit the webinar. It should take just a minute, and your responses can help us create valuable webinar experiences for you in the future. Okay, give me just a second. I'm going to share my screen with the audience. All righty. With that, I'd like to introduce our speakers. First of all, we have Jeremy Sell, our Air and Process Services Business Unit Leader for Tri-Hydro's Air and Process Services Business Unit. Jeremy brings with him 22 years of expertise in overseeing environmental projects for energy clients nationwide. Over the last 10 years, he has actively contributed to diverse air compliance initiatives, including LDAR, B1, Annual Emission Inventory, Cooling Tower MACT, and Refinery Sector Rule gap assessments. Since 2018, Mr. Sell has played a key role in supporting refineries and all aspects of their Fenceline monitoring programs, from initial implementation and monitoring to data management and reporting. Then we have Carrie Ward, who's our sales director for our products division at Tri-Hydro Corporation, and she has 22 years of experience in environmental compliance projects and software development. With her background, she understands the importance of purposeful data and involving industry experts in the evolution of software tools. Carrie's passion lies in helping industry leaders make better, cost-effective decisions by introducing tools that create visibility and opportunities for optimization. She works closely with clients to understand data management goals, identify solutions, and incorporate feedback into product enhancements. All right, Jeremy, I'll turn the presentation over to you.
All right. Amy, if you want to go to the next slide. So thanks everybody for taking the time out of your day to come and listen to our webinar. As Amy mentioned, Tri-Hydro has been involved in the refinery Fenceline monitoring program for quite some time, dating back to when the rule was published in 2016. We've been involved in all aspects of the Fenceline monitoring rule, from pilot studies through implementing full-blown programs, completing root cause investigations for our clients, assisting with quarterly reporting, and even working on some site-specific monitoring plans. And so really what we want to do here throughout this webinar today is take what we've learned over the last several years and provide that information to you guys so that you can kind of be positioned to get your programs up and running and thinking about, how you might implement a program for your facility. Next slide. Through the last several years, the biggest things that we've learned from implementing Fenceline monitoring programs is, firstly, pilot studies certainly can be a very valuable component to your program. A lot of facilities have decided to do this ahead of time to get an understanding of what is out there, what issues they might have at the site, and actually a lot of them have been able to kind of make some corrections before the compliance period hits. So doing a pilot study is a good thing. Common areas that we have seen problems, storage tanks tend to be kind of the biggest impact that we see, and especially tanks that have, for the refinery rule, have benzene in them at high concentrations and they're located close to the fence line. Definitely causes issues. Those tanks are meant to have some emissions, and they certainly do. So loading racks are another place that we've seen a lot of issues, and wastewater treatment operations, and you can kind of correlate that to the enforcement initiative that EPA has with looking at wastewater systems and QQQ programs at the refineries. Third one, if you do identify issues, make sure you take the steps to address them. We have a facility that we worked with early in the process, identified a problem, didn't make the corrections that needed to be made, and hit the radar with EPA and are now in the process of negotiating consent decrees. So definitely, you're collecting that data. You need to make sure that you're doing something with it. Training your sampling team is another thing. There's a lot of moving parts in this, and having a process for the field crew to use to make sure that they're doing things consistently, repeatably, not transcribing errors, doing those type of things. That will save you a lot of headache down the road. And then lastly is site-specific monitoring plans really can be a valuable resource. Certainly there's going to be facilities that have neighbors, just adjacent fence lines shared, off-site sources contributing. The challenge here is, again, this kind of ties back to that pilot study piece, is it takes a fair amount of time to kind of understand what those off-site contributing sources are and to come up with how you would do that site-specific monitoring plan. So definitely need to think about that if you have concerns about an adjacent property owner. Next slide. So the applicability of the HAN fence line monitoring rule really applies to SOCMI and several polymer and resin source categories. Again, you need to be a major source, so you got to have a major source threshold to be subject to this rule. And then lastly, the facility must use, produce, store, or emit one of the chemicals listed here. And that will bring you into having to really think about what your fence line monitoring program is going to look like. Next slide. So this is kind of a draft regulatory timeline that's out there. EPA published the proposed rule back in April of 23. We are anticipating seeing a final rule. EPA actually has a compliance deadline of March 29th this year. And so from that, a year after the final rule is published in the Federal Register, facilities are required to begin fence line monitoring. A year after they begin monitoring, they're required to start reporting their fence line monitoring data. And then 3 years from publication of the final rule is when corrective action and root cause analysis will be implemented. And the reason there for the delay is there are some provisions in the other parts of the HAN rule that are requiring controls to be put on other emission sources. And so it's trying to address some of those issues ahead of time before they're really trying to figure out where the problem areas are. Just as a reminder, this is, again, everything we're talking about here today is proposed. We don't have a final rule. We don't expect to see huge changes between now and the final rule, but there certainly could be some things that need to get updated from the discussion we have today. Next slide. So for people who haven't been involved with passive diffusion tube sampling, this is just some photos to kind of orient to some of the terminology that we'll use throughout the presentation. First picture there is a set of sample tubes that you get from a lab. Each lab kind of has their own way of doing it, but looks very similar to this. There's a Pelican case that includes tubes. You can see in the second photo, there's that tube comes in, and those are the green caps you can see in the container. That tube in the second photo has both end caps on, so it is not being exposed. If you look at the third photo, there's a blank in there, so the tube on the left has both caps on, the tube on the right has the diffusion cap on, and is actually uptaking emissions that are in the ambient air around it. And then we talk about sample shelters, and you can see one in the field, and that, as well as the one sitting on the tabletop there. And really the intent there is to protect the tubes from weather. So kind of give you an idea of what the sampling will look like in the field. Next slide. So the Hahn Fenceline rule has basically two different methods. We just looked at the passive diffusion tube sampling. There will also be a SOCMI canister sampling, and what we're talking about here for sample siting using method 325A is intended for the passive diffusion sampling. And so kind of the first thing that's important here is the fence line, and what is the fence line. You know, the rule gives a little bit of latitude in terms of what the fence line is. It needs to be under the facility's control, and so you need to own the property. It doesn't necessarily have to be the boundary of your ownership. You can come in from the property boundary. You can't go out. So looking at the monitoring perimeter, this is how we start out. There's two methods under method 325A that you can use to determine your sample station siting. The first one is the linear method. This is intended for facilities with irregular shapes. And so this rectangle on the right side, not the best illustration of an irregular shaped facility, but if you were to have one, you would determine based on the perimeter, monitoring perimeter for your facility. If you're less than 24,000 feet, you're going to divide the perimeter by 12, and that would be your spacing. If you're greater than 24,000 feet, then you're required to have a sample station every 2,000 feet. And as you can see in the photo image there on the right, the tanks that are dark green have VOC sources in them. And so there's a provision, if you have a VOC source that's within 50 meters of the fence line, you're required to add an additional monitoring location between the two primary locations. One thing that comes up fairly frequently is small disconnected areas. So if there were to be a loading rack that was further away from the facility that the facility used for barge loading or something like that, the small disconnected areas under 325A, kind of a very generic sample station siting for those, but it's 500-foot spacing and a minimum of 3 locations. And so depending on the size of the facility, certainly that number could add up relatively quickly. Next. Looking at the radial method, this is intended for facilities of regular shapes. And so you find the centroid of your facility, you draw every 30 degrees, 20 degrees, or 15 degrees, depending on the acreage of your site. So if you're less than 750 acres, you're going to do every 30 degrees for 12 locations. 750 to 1,500 acres, you're going to do 18 locations. And then if you're greater than 1,500 acres, you're going to look for 24 locations. Again, same kind of concern here with VOC sources being close to the fence line. You can see towards the top there are additional monitoring stations located there to account for those VOC sources within 50 meters of the fence line. And then the disconnected areas are similar to what we would do in the linear method for this approach as well. Next slide. So kind of the nitty-gritty details on the passive diffusion side. So passive diffusion tubes are intended to be used for benzene, 1,3-butadiene, chloroprene, and the ethylene dichloride analyses. That's 4 of the 6 analytes that we're worried about when it comes to the Hahn Fenceline rule. And so if you don't have the other 2, then you would only be doing the passive diffusion side. The sample stations, as we talked about, the shelters are intended to provide cover for the tubes. They need to be located on the fence between 1.5 and 3 meters in elevation above the ground, and they're required to be surveyed to an accuracy of at least 3 meters. The sampling period for the tubes is a 14-day sampling period that is defined in the rule to give you a little bit of flexibility that it can be 13 to 15 days. The other thing to note here is there needs to be a weather station associated with the sampling program. A lot of facilities, the rule, if there's a weather station at an airport that's within 25 miles of the facility, that tends to be the easiest one, just from getting consistent data and not having to worry about calibration of the weather station and those type of things. And so that's what a lot of the sites are using. When you get into a site-specific monitoring plan, certainly you'll have to have a site-specific weather station as well. Analyses under here are performed under EPA Method 325B. Typically, when we work with labs, the cost of the tube rental, the cost of the analyses, all of that, the shipping is kind of included into what your cost is going to be. And then the QA/QC samples, depending on the number of sample stations you have, if you have 19 or less, you're going to have 1 field blank and 1 duplicate that you do each sample event. If you have more than 20 locations, you'll have 1 field blank again, but you will increase to 2 field duplicates. Next slide. Moving on to SOCMI canister sampling. So this is some images of SOCMI canisters if you're not familiar with them. The first photo, the Fenceline rule for SOCMI canister sampling, the method 327 requires 6-liter SOCMI canisters. So that would be the ball-shaped one on the left in the first image. You can see kind of the top of what the SOCMI canister looks like in the middle. And then on the right, there's a SOCMI canister that's in the field and has a flow regulator, that kind of pink device on top of the SOCMI canister that's allowing a certain amount of flow into the canister to kind of regulate that sample over a duration. And for this, it's going to be a 24-hour sample period. Next slide. So for SOCMI canisters, sample station siting, it's a little bit different from what we do with 325A. And of course, we're in the same regulation, but we're using meters instead of feet. So in this one, again, we're looking at the monitoring perimeter. If we're less than 5,000 meters, we're just going to have 8 locations. The caveat with this one is one of your locations has to be closest to the source of target analyte for the site. So if you are monitoring for vinyl chloride or ethylene oxide with SOCMI canisters, you're going to have to put one of those sample stations is going to start adjacent to the closest source to the fence line. For 5,000 to 10,000 meters, you're going to have 16 locations. Again, you're going to have that one that's closest to the source. And then greater than 10,000, there will be 24. EPA was a little more specific in terms of the disconnected areas here, and that, if you recall on 325A, it was 500-foot spacing with at least 3 locations. Here, again, it's based on size, not the perimeter, but the size of the area. And so if you're less than 50 acres, you're going to have 2 locations. One will be in the prevailing downwind direction, the other 180 degrees on the opposite side of the property. If you're 50 to 150 acres, then you're going to have 4 locations. And again, one with the closest sample station closest to the target analyte source. And then if you're greater than 150 acres, you're going to look at using the main station siting that we talked about previously, where you're looking at, if you're fence line perimeter, you'll have 8 locations, 16 or 24. So a little different, a little more specific in terms of the sample station siting for SOCMI canister sampling. Next. As I mentioned, EPA Method 327 requires 6-liter SUMA canisters. And again, we'll be looking at vinyl chloride and ethylene oxide using the SUMA canisters. In the proposed method, there's requirements that it needs to be under a shelter. A little trickier for those since they're a little bigger than tubes. They need to be located similarly off the ground and surveyed to the same accuracy as you would your diffusion tube locations. These samples will be done every 5 days and will be a 24-hour sample period. So a little more time intensive for the field people doing the work. You're going to have to come one day, put the canisters out, come the next day and collect them. And then a little more frequent in terms of the duration of sampling. Each sample event, you will only have 8 locations. So if you recall, based on the perimeter of your fence line, you're either going to have 8, 16, or 24 locations. Depending on that, it'll determine kind of how you rotate through your sample. So if you only have 8 locations, you're going to sample every location during every event. If you have 16 locations, you're going to alternate between events. So you'll do odd numbered stations one time, the next time you'll do your even number. And then if you have 24 locations, you would do every 3rd sample location and rotate through that every sample event. Probably the biggest thing here is this EPA Method 327, and you know, currently I know there's facilities that are wanting to do pilot studies. There's not really a lab out there that I'm aware of that is set up to really do this or accredited to do this, and so that could be a challenge. There's a lot of complications in the EPA Method 327 in terms of the detection limits they're looking for and interferences from other things, and the QA requirements that are involved in Method 327 are pretty intensive. And so not a great answer there, but hopefully when we get some revised rule language out here, we'll see some changes to Method 327 as well. And then looking at our QA/QC samples, similar to the tubes, we will have 1 field blank and 1 field duplicate per sample event, and that is not dependent on the size of your facility, so that's consistent across whether you have 8, 16, or 24 locations. Next slide. So how does EPA regulate under this and enforce under this? You know, the regulatory action level is delta C, and so this program is going to be a little bit different than the Refinery Sector Rule in that there's going to be multiple delta Cs. You're going to have delta C for each constituent that you're looking at, and your delta Cs are going to be calculated slightly differently depending on your sample period. So what you're doing is you're taking the average of your last year's worth of delta Cs to come up with what your annual average is. And so for diffusion tubes, that's 26 events in a year. And for the SUMA canisters, every 5 days is 73 events in a year. So your event delta C is going to be your highest detected concentration of that constituent minus the lowest detected concentration during that single event. And that's where you come up with your individual event delta C. And then the action levels, you can see here, benzene is consistent with what the Refinery Sector Rule was. Looking at chloroprene and ethylene oxide, those are super low detections and are definitely going to cause some challenges from a laboratory side of things. Next slide. So if you have an exceedance of your annual average delta C, it's going to trigger a root cause analysis and corrective actions. And so the rule requires within 5 days of determining that you've had an exceedance, you have to begin a root cause analysis. Initial things that you can do for root cause analysis include, you know, going out and doing method 21 LDAR inspections with a TVA to see if you can find a leak that's contributing. You know, doing visual cameras with an OGI camera, talking with operators, understanding was there an upset, was there a maintenance activity that happened during the time that caused some increased emissions, And then doing additional more frequent sampling. So instead of having a 14-day sample period with your tubes, maybe you need to coordinate and you're going to do daily samples or 5-day samples or something like that. If your root cause analysis doesn't lead you to what the problem is within 30 days, this is different from the refinery sector. The EPA is requiring that you implement real-time techniques. And so a real-time technique could be an open path system. It could be a point monitor like a GC that's deployed in the field. And the intent there is that you're getting more real-time data to help you better understand what's going on. If after 48 hours of doing that real-time monitoring, you still don't have a source identified, you're either required to add an additional monitor or to relocate the monitor. And this continues every 48 hours until you figure out what that source is. The timing on completing your initial corrective actions and your root cause analysis is 45 days. So from the time that you determine you have an exceedance, you have 45 days to complete that. So, and then the last piece of the corrective action program is if you have implemented your corrective actions and the next sampling period, your event delta C is still above the action level, then you're required to submit a written corrective action plan. And so that's, there's some details in terms of what needs to be in that corrective action plan. The other thing that will trigger that is if it's going to take you more than the 45 days allowed to implement those initial corrective actions, then you have to submit a corrective action plan. And those written corrective action plans are going to be due 60 days after that 45-day period is completed. Next slide. So site-specific monitoring plans, I talked about these a little earlier. You know, really site-specific monitoring plans we've seen have been a necessity for some sites, especially in places where we have kind of a refinery on top of a refinery on top of a refinery. And so assuming we're going to have some chemical plants that kind of hit this same sort of adjacent property issue. And so your site-specific monitoring plan has to identify what the off-site sources are, and it needs to be specific in terms of what those are. It needs to identify what monitoring stations are being impacted by the off-site source. So there may be places where you have multiple stations impacted by one source. There may be separate stations kind of across different perimeters where you're being impacted by different sources. The location where you're going to install additional monitors, and really typically this is adjacent to your tube so that you can make an accurate correction on what the concentration is there. You have to submit how you're going to do your calculation. And really a lot of this gets to why in the lessons learned side was we need to have a lot of this information in data in hand to come up with these correlations and calculations before we can actually submit a site-specific monitoring plan. You need to describe your measurement techniques, or are you using a GC, or what type of instrument are you using or technique are you using to monitor what you're going to subtract out from an offsite source? And then also a description of how you're going to deal with times where you don't have any sort of significant wind. And because really that's where you're kind of looking as wind direction is going to drive when you subtract off an offsite source. Additional things to think about for your site-specific monitoring plan include, as I said, you got to have an on-site MET station, which requires a little bit of QA on the site's part in terms of making sure you're meeting calibration requirements of those MET stations. You've got to have the data to support what the offsite sources are. And really the calculations here can get pretty complex, and having a way to automate those is really pretty critical in the scheme of things. Next slide. Okay, so that everything I've talked to to this point is pretty much a chemical plant that's coming in that hasn't been doing refinery sector rule Fenceline monitoring. This slide will kind of focus on, okay, you're a refinery and you have a HON unit located within the perimeter of your refinery. What do you need to think about? And really, what we would recommend at this point is using the same fence line that you have used for your facility, understanding that your HON unit may only be a small portion of the facility. Certainly there's some things to consider there in terms of size and number of sample locations, but in terms of interferences from other things going on at the refinery, probably best to still have the main refinery boundary. The other thing is it gives you a little bit of distance from the source to allow some of that, some of the emissions to kind of dilute as they go out. You need to determine which chemicals are going to be used, produced, stored, or emitted from that HON unit. And so looking at the 6 chemicals, which ones are coming from that unit. Again, if you have benzene, butadiene, chloroprene, ethylene dichloride, those are going to be part of diffusion tubes, and really, there's not, 325B doesn't have published uptake rates necessarily for all of those at this point in time, and so they're still working through kind of finalizing some of that. But really, you would just need to add those to your diffusion tube sampling you're doing already for benzene. And depending on, we've talked with a number of labs. Most labs are thinking that they can probably get all 4 of those on one tube. Some of them are concerned about one or the other of the chemicals and think that there may be a need for 2 tubes. So could be a little additional tube maintenance to jump into if you have those. If you determine that vinyl chloride and ethylene oxide are emitted from your HON unit, then you're going to have to go through and come up with your sampling network that we talked about for the SUMA canister sampling and set up that program. Again, we anticipate, because this is under 2 different rules, you've got your RSR Fenceline monitoring side, and then you're going to have this, that refineries that have a HON unit are going to end up having to report under 2 separate regulations. And if benzene's a source in both, you'd probably be reporting redundant data. But time will tell when we see how the reporting comes out on that. So with that, I've kind of wrapped up the regulatory side of the Fenceline piece, and I will turn it over to Carrie, and Carrie will talk to you about data management aspects and some of the lessons learned that we've had there.
Thanks, Jeremy. Yeah, so thanks again for attending our webinar and hearing what we have to say about our experiences. So in 2016, Tri-Hydro created Fenceline Pro to help refineries streamline the data collection, analysis, and reporting aspects of the benzene Fenceline monitoring rule. And at that time, folks were only interested in reporting what was required. But since then, they've realized that having better tools to see what data from their stations look like, folks have asked for more features in our system to help them better control their narrative. And so Tri-Hydro's solutions continue to grow and incorporate regulatory changes like the HON update, but they also evolve based on that user feedback network. Next slide. So incorporating additional constituents into the system was something that we included years ago, because we also had some folks from Canada and they had additional constituents beyond benzene. But adding features to handle the new analytical method and the proposed action levels for each of the new constituents will probably be the most comprehensive update that we have made to Fenceline Pro in almost 8 years. So I'll touch on several of those new features as I go through the next slides, but my focus will be on explaining all the moving parts of data management that the new facilities will be facing, and then also presenting our lessons learned in managing those moving parts in an efficient way. Next slide. So let's start off with a sky view of those moving parts. Once you have your fence line set and have determined the location of each of your sample stations, you'll need to think about how you're going to manage all of the data before the sampling phase begins. Because each step of the workflow produces really important information that often begets the very next step. So in this diagram, the circles are representing the tasks that are performed, and then the squares are representing the data that's captured and processed during each of those steps. So with this diagram, I hope to convey my first lessons learned. Find a data management system that's reliable and plans to be around for a while. So once those refiners that are using Fenceline Pro were up and running, they started to look for cost savings. Some changed contractors, some took the work in-house, some changed labs, and others were able to reduce their sampling frequency at their sites. But throughout all of those changes, Fenceline Pro was their constant, because we've worked with all of the labs that run the 325-day or the 325 method. It was easy for programs to switch between labs, or for labs to bring on new project managers to help capture that expanded workload. Next slide. Now let's focus on the routine data flow. So starting with field data collection. When a new event begins, you'll need to let the tubes that came from the laboratory equilibrate to the monitoring environment. So we capture that information in the screenshot on the left at the very top of the screen, that equilibrium phase. And then below that button, we start our first monitoring location. So with each cycle, you're going to be collecting the tubes or the sample media that was put out there previously, and then placing a new round of tubes. And so with each of those methods, you're going to need to capture several of the data components that I've listed out here. The information you're recording for both methods is going to be consistent, like I said. Field issues, though, I wanted to call that one out specifically. So this was something that we didn't originally capture when we rolled out the application, but something we added on later once the programs got into motion. And there was a huge flood that hit the Midwest. And so some of the facilities in Oklahoma experienced severe flooding, and that the waters came in so high that they took out several stations and tubes. And so the next time that the field crew went out into the field to retrieve those tubes, they were missing, and they didn't have a way to capture that because we've digitized the process, and the app didn't account for this scenario. So we added in those features so that they could capture really important information that's happening in the field and when a tube is missing, and then that information becomes part of the data in their system, and then also gets relayed to the laboratory so they know what to expect when they get that tube shipment back to them. So with this scenario, I want to hit my second lessons learned. Maintain strict data integrity standards within your system. Your data management systems should be your main system of records. So you'll want to capture as much of the original source data as possible when it occurs. Okay, next slide. Another major data source is the weather data. You'll need to capture continuous weather data, including wind direction, wind speed, temperature, and barometric pressure. So this data is used to process analytical results by the laboratory, and also in case you need to conduct your root cause analysis. So pulling weather data into your system will provide you with tools to respond as quickly as possible. And so here comes my third lessons learned. Where you can, use your nearby airport weather data if you can, because the RSR rule says that if your facility is within 25 miles of airport, then you can use that airport data. It'll be a huge cost savings if that works out for you, because their data is continuous and it's easy to capture that and stream it into a system. However, if your nearest airport isn't within 25 miles, then you're going to need to install one at your facility, a weather station, or if you already have one, you could use that one, but we recommend getting it evaluated against the regulated criteria, because in the RSR, there's some pretty strict information about what needs to happen with that weather station. You're also going to want to find out how easy it is to connect to that weather station, because we're finding out that some of the stations that were installed back in 2016 when the rule started are already out of date, and some of those components are a little clunky and don't easily stream data into other networks. And so, you know, if you need help assessing what you have on site, we'd be happy to help out with that. Next slide. Let's see. Okay, so I'm going to start this slide off with our next lessons learned. Eliminate communication gaps between the field and the laboratory. So the lab, like I said before, needs the average temperature that's recorded across the entire monitoring period in order to provide the calculated volumetric results. So this is typically a huge communication gap that we see, and it can cause delays in receiving your data, that and the field issues that aren't being relayed back to the laboratory. So Fenceline Pro automatically generates a COC once the field data has been uploaded from the mobile application into the system. Also pulling in those field issues and then compiling all of that information into the COC. So displaying the field issues, the comments, and that temperature and pressure. So what you see here on my screen is actually a printed version of that electronic COC, but the actual file that we produce has another tab. It's really cool because this idea came from the laboratories that interact with Fenceline Pro, and they asked for a tab that produces the COC information in a digestible format for their systems. So some of them will come into Fenceline Pro, download that COC when they are anticipating their tubes from you, and be prepared, be able to set up their system and get ready to receive that information, know it's coming. In fact, then once the results are ready, those labs will also log back into Fenceline Pro and upload those results. So even minimizing more that time that it takes to get their data that they've processed to their customers. And so we think that that might be more commonplace for the labs that end up analyzing the 327, because they're going to need to see that COC and analyze those results on a more frequent basis for those other constituents. Okay, next slide. So finding a reliable system that can pull all your data sources together will help you automate and provide efficiencies for your program by eliminating communication gaps, expediting the results and the response time, and then simplifying that reporting process in the end. So streaming in weather data, data from your continuous monitors if you're doing an SSMP, facilitating that easy and verified data upload from the lab, and then automating your COC process are huge time savers when you need to review and report your data. So having it all in one place allows you to automate other steps in the process that provide checks and balances. So this is my fifth and final lesson learned that we had over the years. Set up notifications within your system. So reminders when samples are due, help your crew to multitask with other, continue to stay efficient, but without missing a monitoring event. That's important. You'll want program logic in place to ensure that all of the samples are being collected in the field along with the QC samples. And then laboratory or logic for when the labs come in and load their samples, a little data validation to make sure that the data is coming into the right site and is pulling in the right, the information for all the samples that were captured. So when the monitoring cycle is set in motion, these notifications can help avoid complacency or errors during staffing turnovers. But one of the biggest returns from streaming your data into one system is setting up notifications that will automate your Delta C and your rolling average calculations. So when there's an exceedance, you're the first to know about it. Next slide. Okay, so the Delta C alerts, or the rolling average exceedance alerts in Fenceline Pro, are set up to send you an email or a text notification when that occurs. As soon as the laboratory results have been uploaded, that'll trigger the alerts. And then when that's activated, that alert will come to you with a link to this page that I have on my screen right now. So this is our alerts page, and here you'll have all the information that we've been pulling together for your system in one spot. So up in the upper left quadrant, you can see the last 3 events, the Delta C, triggering that event, and also the weather, let's see, the temperature and the pressure. On the right, you have your site map with your locations and those results pulled in, indicating where that high reading was. And then down in the bottom, so earlier when I was talking about the mobile app capturing field activities and information like that, there's a spot for them to record any activities that are happening at the site during the monitoring event that they notice. So for example, if they're out there changing out one of the tubes near one of the stations and there's a tank cleanup, maybe they jot that down and then they can forget about it, because once it's uploaded into the system, you'll be able to pull it all together with that sampling event and see maybe that was something that triggered the issue. So then on the bottom right, we're also pulling in that average weather data during that reporting event that triggered the alert. And then from this page, you can drill down into the other analytical tools that we have that are in, next slide, tabular format. So here you can view all of the results, sort and search and filter on them, and then export them into Excel. Next slide. We have them in graphical format. So Fenceline Pro has 6 graphs that we create with the data as soon as it's uploaded into the system, and they'll track the Delta C, the rolling average, pull in the weather data so you can see everything at once. This is an image with one of those showing all of the results across the site. So when the new constituents are added for your facility, we're going to pull in that additional graph to represent each of the compounds. And then finally, next slide, seeing it geographically. So we display each period's results and the windrows for that period across the results. We lay that out all on one page, and because we're streaming in weather data on an hourly basis, you can actually animate this windrows so that it'll tick through the like redraw a windrows for each day within that monitoring period, so you can see if maybe there was a weather event that you know, blew the constituents more concentrated in one region than you're used to seeing, something along that line. But having that data and being able to animate that is kind of helpful when you're doing your root cause analysis. So those Fenceline Pro customers that are on this call, I just wanted to say that if you have some ideas about the features that I've talked about, we'd love to get your thoughts and feedbacks, any wish lists that you'd like to see. Just shoot those to our support team so that we can take those into account and make sure that we are incorporating your interests and your feedback as we're adding those components to the tool. Next slide. Okay, so the final component of an effective database management system is reporting. So the EPA requires refineries to report Fenceline monitoring results, the sample period Delta C, and the rolling average every quarter. They must populate the template that they provide, the EPA provides, because it's going to be uploaded into the EPA's SEDRI system. So this is an example on my screenshot here of what that SEDRI report looks like, and it's 6 tabs. So Fenceline Pro will generate this. It'll populate that template for you, and then at that point, you're just reviewing the data before you upload it into the system. And again, here, just wanted to reiterate the importance of data integrity and making sure that your system of record is the main primary source of all of the moving parts of that data process, so that when it comes to the reporting period, your report's going to have all of the right information that occurred during those monitoring events. Now, the image on the right is the flash report that our system creates. That's created automatically on a period by period basis. It includes the actual results for each station, the highs, the lows, the delta C, the rolling average, and also brings in the QC samples that were captured. So this example on my screen here is showing benzene, and then we're going to add in all of those components that this report has for each of those constituents that you are monitoring for on your site. Like Jeremy said, we are anticipating that there will be separate reports. And so I don't think that we saw this version of the SEDRI report until, after that, probably at least halfway into that first required year that you were capturing data. So it took a while to see that, but we'll be ready for it when it does happen, and we'll include that report in here as well. Okay, next slide. All right, so that's it. Just wanted to recap those lessons learned. So one, have a data management system that is reliable and plans to be around for a while. Within that system, you want to maintain strict data integrity standards because the data is going to go public. And this is the link to that public benzene Fenceline monitoring dashboard. I know it's not a link you could probably access, but if you Google those words, you'll probably come up with the WebFire site. Use a nearby airport station if you can for weather data. Eliminate communication gaps between the field and the laboratories in order to expedite results, and set up notifications. And so that's it. Back to you, Amy.
Great, thank you both, Carrie and Jeremy. Lots of good information here. Lots on the docket for what we need to do in the future. Let's move on to our Q&A. For those of you that are online with us, if you haven't already, please type in your questions in the attendee panel. And if we run out of time together today, we'll follow up with answers to your questions via email or even a phone call after. All right, so Jeremy, we'll start off with you. Number one, did the passive diffusion tubes provide data for more than one analyte, or would one tube need to be used per analyte?
So as I mentioned, I think most labs are coming back and saying that they're thinking that they can probably get all of them on one tube. There is a couple labs that have mentioned that there's some problems with one of the constituents that they would need to do separately. So it'll depend on what you're doing, but certainly not one tube per analyte, but probably up to 2 tubes for the full list of diffusion samples.
Great. And kind of along those lines, can the benzene diffusion tube carbon pack also be used for 1,3-butadiene?
So I believe that is the case. I think that's what Canada is doing in their Fenceline rule, is they're doing benzene and 1,3-butadiene, and I believe that they're using the carbopack for that.
All right, thank you, Jeremy. Carrie, you mentioned streaming in continuous data. Did you mean data from GC monitors? And why would that be important to stream into the same system?
Yeah, that's a good question. So that is what I meant. GC monitors or any other continuous monitors that you've set out in your perimeter or within the station, and you are using that possibly for, Jeremy went into the SSMPs. So we've seen refineries that have GC monitors on site, and they are part of their SSMP. So we're streaming in that data and automating that corrected benzene calculation that's within their SSMP to reformulate their delta C calculations. So, you know, that's just another piece of data that gives you your Fenceline picture. And so, you know, we recommend trying to find a system that does that for you.
Great, thank you. Jeremy, for large facilities with 24 locations using canisters, will the delta C still be 73 for a year of data?
Yep. Yep, that would still be, you're still looking at a year's worth of data. So essentially what they're saying is they're rotating around each location. So representative of total site conditions throughout the year. So it would be still the 73 would be your delta C.
All right, there was a question, when will the presentation and replay be available? We will have an email out to those people who are registered by the end of this week. So stay tuned for more information. Carrie, you mentioned that some refineries were able to reduce their sampling frequency. Is that something that the HAN rule covers?
You know, I'm not entirely sure. Jeremy and I went through the rule, and maybe Jeremy, I'll let you take that one. But I believe right now that is a component of RSR, but not necessarily the HAN update.
Yeah, there's nothing in the proposed language that addresses reduced sampling frequency. So in the refinery sector rule, so the action level was 9, if your detections were below 0.9 for, I can't remember how long it was, a certain period of time, then you could go to reduced frequency, kind of like you do skip period monitoring for LDAR. I don't see that provision in the HAN Fenceline rule at this point.
All right, I think we have maybe time for one more question. If I have an event delta C exceedance, but my annual average delta C is below the action level, do I need to complete a root cause analysis and implement corrective actions?
So complicated answer. The answer would be formally no. In terms of implementing a formal corrective action and root cause analysis, it's your annual average delta C, but from understanding where the problem is coming from, we would recommend that be a best practice for the facility to, make sure it only takes a couple of those big hits that can really impact your delta C for a long period of time. And so if you do have something that comes up, making sure you're understanding what it is and getting it taken care of.
All right, any other questions from our attendees today? We have just about 2 more minutes together. All right, I guess we'll wrap it up then. If you do have additional questions, please make sure and reach out to us. There is an opportunity in our exit survey to ask those questions at that time. There's also an opportunity to request some one-on-one time with us to discuss your interests and concerns further. Also, as mentioned before, a recording of today's webinar will be delivered to your inbox later this week. Carrie, Jeremy, anything else for our audience at this time?
Not for me.
All right. Well, thank you everyone for joining us, and we look forward to continuing our conversation further with you. Thank you, everybody. Have a good day.